Hi Spring fans, welcome to another installment of Spring Tips. In this installment we're going to look at the Scala programming language. So let's build a new application. We'll go to start.spring.io as usual, and we're going to use Spring Boot 2.0 M4, the latest and greatest bits, and we're just going to call this the Scala artifact just because it's a demo, right? And we'll use reactive web support, we'll use reactive MongoDB support, and we'll hit generate. Now notice that we of course haven't specified the language here, right? We don't have any default support out of the box for Scala, but it's pretty trivial to add, and there's no reason you couldn't use any language, even ones that we don't have here, that support annotations and objects on the JVM. So that's sort of what we're going to demonstrate here in this video. Now, we have a new zip file. It's been downloaded to the here. Okay, open that up. Alright, so the first thing that we need to do is to change the Maven build to reflect the fact that we're going to be working with Scala and not with Java. And there's a few things that we need to do here, so let's walk through it. I have pre-canned snippets we can borrow. So the first thing we're going to do is change the build stanza, right? So we'll go down here, and the build stanza contains our Maven plugin for Spring Boot, which we still want, but we want to add one more plugin. So I'm adding the Scala Maven plugin, which is a very popular dependency that you can use, a pretty popular plugin that you can use to compile Scala code. And of course it relies upon there being a source main Scala and a source test Scala directory, so we should see to that there are. Actually, I wonder if we can just rename this. So F6. Okay. Rename. Is that possible here? Show in files. All right. All right. We'll re-import the project. Okay. Scala. We don't need this, of course. So let's get rid of all that. And we don't need the test code either, so we'll get rid of that. Now we have the build plugin. Let's now import the dependency management. So we'll get that as well. And paste that here. This is because we need the Scala library. We need to make sure we have the right one true version of the compiler on the class path, or the runtime on the class path. And this is because we're going to use a different project that support the Reactive Streams specification, including, of course, Project Reactor and Spring WebFlux, but also, as we'll see later, other projects. And the other projects want the slightly newer, just a few months newer version of Reactive Streams 1.01, which is fine, right? There's no reason not to use it. It's backwards compatible, so we'll add that to the class path and ensure that everything gets moved up to that revision. So with that, let's see what else we have here. We have the dependency. We need the dependencies themselves. Okay, and we'll copy that to the clipboard. And bring in the Scala library, right? There we are. And finally, we need to make sure that our build plugin, which references certain properties here, Scala.version, actually references valid properties, right? So we're going to bring those properties in here as well. All right, so Maven, re-import, and now we have a directory structure that should work as expected. So let's create a new package here. We're going to call this the tweets package. So the domain model is going to be something that I borrowed from some of a very common example from Lightbend, right? So I'll use that here. So Scala tweets, and we've got a package. Now let's create a new code page. We're going to say tweets.scala, and we'll specify package, right? So I'll say package is tweets, and we'll create some classes, right? The first thing we need to do is to create the entry point into the Spring Boot application. So class application, Spring Boot application. Okay. Now, just as with Kotlin, Scala programs don't really have a concept of statics, so you create what's called an object peer, like this, and this object peer is going to extend. In this case, it's a Scala type called app, and you don't have to do anything else. You can just write code in this in the center of that, and it'll work. So class of application, and of course the second parameter are the arguments. So like that. Very good. So there's our arguments, or our Spring application itself, and we're just going to use a simple domain model here. We're going to use the domain of tweets, right? So we're going to store this domain in the database. So we need to first design that domain. So we'll say case class author, and we'll have the handle of the author. There we are. We're going to have another case class hashtag tag string. Okay. We'll have another case class tweet, which will have the text string and author. Now, a case class in Scala is a convenient way of defining an object with simple properties that or for which we want to have getters, setters, and properties automatically generated, right? So we get that for free just by defining this case class. We can map this to, we can use it just like any other object. It's just that it has a special benefit in the Scala language, because you can also use it for pattern matching, right? Which is a slightly more advanced feature that you'll see a lot of in the Scala world. Okay, so I'm creating MongoDB document here. I want to tell Scala to turn these fields, these constructor arguments, into Java Bean property. So I'll say at bean property, right? So at bean property. There we are. And then finally, I want to tell it to turn these individual things here into Spring Data document IDs. So at ID, and we'll do the same. Right? Actually, that's fine. We can just leave those as they are, and we can do the same here, right? Now, this tweet will have a nested collection of hashtags, but those hashtags will be synthesized based on the text of the tweet itself. So let's create that here. We'll say hashtags equals, and it's going to be a Java util.set of hashtag equals, and we're going to take the body, the constructor argument there, the text, and we'll split it into that, and then we'll collect the results. So let's see. Dot collect, returning this, and we'll say that we want to say that we want to get the elements in the array, and we want to merge them together. We want to collect them together. So we're going to say using pattern matching here, we're going to use a convenience in pattern matching, which allows us to automatically down type the argument here. We're going to say case t if t dot starts with, then let's return a hashtag, right? And the way we're going to do that is we're going to say t dot replace all, and so keep in mind we have strings here, and we're going to make sure that whatever string we get, we're going to replace everything that isn't a word with just an empty space. So our regular expression here will be replace everything that isn't this and a word with this, just an empty space. And let's also lowercase it just to get a canonical sort of definition here. And we'll return that into a Scala set. Now this is not a Java set. In order to get that difference, we need to actually use the Java converters type under Scala.collection, and we can turn that set into a Java set here. All right. So there's our hashtags field. Let's also turn this into a bean property, and there we go. This will work just nicely, just perfectly with your standard marshalling infrastructure like Jackson, for example. Now we want to actually have some sample data in the database, so let's create a initialization object, and this initialization object is just going to be a application runner, as you've seen me do a number of times before. So we're going to initialize some data here, and we're going to return application runner, Okay. And it's a lambda. It lends itself to being a lambda, so it's going to expect arguments and it's going to throw an exception, and otherwise it's fairly straightforward. So we can actually just define the lambda here. Now, this is the first time you're seeing me define a custom lambda here. It's doing type inference, so it already knows that this is the application arguments that's expected from this interface. It supports the same kind of functional interface mechanism that Java 8 introduced, right? So this is very convenient. But in Scala, functions or methods are a first-class citizen. So you can create a lambda that doesn't have any relationship to a functional interface. You can just create a lambda that a standalone lambda that exists just for the sake of existing. It doesn't have to conform to a particular type. So in this case, we've got a bean that's going to return this functional interface and implementation of, and in this we're going to initialize the database itself. So let's create a repository to manipulate the tweets. So we'll create a repository using Spring data again, but in Scala, interfaces are something called a trait, and they also have the ability to specify behavior, just like Java 8 interfaces now can, right? So traits are for our purposes the same thing as as an interface, but they can do a lot more. So we're going to say tweet repository extends reactive Mongo repository managing entities, and notice that the brackets here are the equivalent of the angled brackets in Java. So it's going to manage types of tweet whose primary key is of type string, and we can now inject this into our bean definition, tr tweet repository, and to make short work of things, I've already pre-selected some tweets that we can use. So there we are. There's some tweets from some people in the community, myself included, and then 2 folks from the Scala and Akka and Lightbend community. And we're going to use use that sample data, this sample data here, as our example set. So we're going to first of all we're going to call delete all from deleting everything in the database. Then we're going to save everything using the repository, passing in the tweets there. Then we're going to get everything back from the database. Then we're going to subscribe to that data. And here you see I'm doing fairly straightforward stuff. This should look very familiar if you've ever used Project Reactor, right? Project Reactor is our reactive API that underpins the Spring WebFlux web runtime in Spring Boot 2.0 and Spring Framework 5, and you have the ability ultimately at the end of the day to work with Reactor specific project or Reactor project specific types called fluxes and monos. These are subtypes of an interface called Publisher, and Publisher comes from the Reactive Streams initiative, right? And so we saw that dependency on the class path here. We saw the Reactive Streams types 1.01 on the class path. So we're going to use that here in our code, and we're going to take advantage of that commonality there. We're going to take advantage of the fact that other projects integrate with the Reactive Streams initiative, just like we do, for interop, right? So we're going to use that here. We're going to say, I want to print out information about this tweet, and so obviously we'll use a multi-line string here, yet another thing that's really nice inside of Scala, and we'll say t dot dot author dot handle, and we'll print out the hashtag, so t dot hashtags, and then we'll print out a new string. So let's see, we'll say t dot text, and before we do that, let's actually also print out a new line. Okay, so we're using a multi-line string here in Scala. That's very convenient. We're using token. There's a tokenization mechanism that actually lets us dereference variables actually in the strings themselves. They're being interpolated into the string automatically for us. We've got kind of these living templates. That's really cool. And then we're going to print it all out when we see it, right? And we're this is a consumer. We're providing a lambda here, so it should look, fairly straightforward. If you're coming at this from Java 8, for example, this shouldn't be too much of a big of a leap, right? Cognitively, the only thing you'll notice is that we have to use an equals instead of a minus sign, right? Java is a minus sign, equals for Scala. But otherwise, this should look fairly straightforward. Especially if you've used Kotlin, this will look fairly straightforward as well. So lots of cool stuff going on here. Let's see if that works. Let's go ahead and run the application and confirm that we have successfully been able to write these 6 different tweets and their authors. You can see that reflected over here to the console, to the database rather. Okay, there we are. So there's our data. The hashtags and the author and the content of the tweet. Right, it's all there. And now we want to build a service. Right, so let's build a service so that we can build a REST API. So we'll say class tweet service, and we'll take advantage of the tweet repository. And the service is just that it's a Java, it's a Spring object that is annotated with the stereotype annotation service. And for our first bit of functionality, we'll have an endpoint or a service called tweets, and all that's going to do is just return all the tweets. But we can use that now to stand up a REST API. So I suppose the first way to do that would be to create a REST controller, a Spring WebFlux controller here. Okay. And we're going to say tweet REST controller. We'll create an endpoint here, get mapping, array tweets, def tweets, and we're just going to inject the tweet service. So tr tweet service dot tweets. All right, there we go. So there's our REST endpoint. Let's go ahead and see if that works. Now you'll notice that IntelliJ is kind of hinting that I should do better. I should be very explicit about the return value here, right? And that's probably good advice, but because of the very sophisticated type inference in Scala, that would have actually worked had we left it as it was, right? So this is what it's asking me to do, is to be explicit in the return value, and that's probably a good idea, especially if you want to be sure that you don't break something later on. In this case, the runtime is the consumer. Oh, it failed because of the port, right? So it's, in this case, the runtime was the consumer of this method, right? The invoker of this method, but and it would have done the right thing had we returned a reasonable object. But that may not always be the case. So that's probably good advice. So let's see tweets. There it is. There's our tweets that are coming from the database. That seems to be working, right? Now, I want to create another endpoint. I want to create an endpoint that just returns all of the hashtags in all of these different tweets normalized, right? I want to return the unique hashtags because some hashtags appear more than once in different tweets. I don't want to have them all. I just want to get the ones that, I want to get every one tweet hashtag once. So let's create a new endpoint here called hashtags, def hashtags. And in order for this to work, we're going to use the Akka Streams library. Now, Akka Streams is a library from Lightbend, which was formerly called TypeSafe. They're the shepherds of the Scala language. And Akka Streams has some very interesting features, some very compelling features. I think it's, for what I'm doing, for this simple example, I probably could get away with just using Reactor. But that said, there are some interesting integrations for Akka Streams that go beyond what we're doing here, that you should perhaps investigate, and that's the whole point, right? We're not. What I'm trying to demonstrate is that because it's just a JVM language, and because we have interoperability in terms of the Reactive Streams, there's no reason that your world has to sort of ignore this treasure trove of functionality. There's a lot of stuff you could use from that community, from that ecosystem, and you should absolutely do so, right? You can expand the richness of your application by pulling in the best of breed components. And so this is just a simple example. Now in order for us to get the Akka Streams library in the class path, we need to bring in the dependencies. So we'll say deps.as, copy that to the clipboard, and we'll bring this in. So we'll say that we want to use the Akka Streams dependency version that has been compiled for Scala 2.12. And again, this, it will happen that you have different libraries compiled for different versions of Scala, because it's sometimes not easy to keep interoperable or backwards compatibility when they change the language, right? That's, it's just a fact, right? It's just something that happens, and that's okay. It's not a big deal in practice. So you can see we've just bring in the right version. We've got a property here called Scala major.version. We're using Scala 2.12, and we'll bring in this. So now we are going to say that we want to take all the data. So we'll say source, right? We're going to bring in a source type from Akka Streams using the Scala DSL, and we're going to say give us all of the tweets. This is a publisher, right? Remember, in Reactor, the flux and monotypes extend from publisher, but in Akka Streams, they have their own. It has its own processing model, its own pipeline definition model, and it's easy enough to originate the data that feeds into the Akka Stream pipeline from a Reactive Streams. It's easy enough to originate the data that feeds into the Akka Stream pipeline from a Reactive Streams publisher. So that's what we're doing. We're saying create an Akka Streams source from a Reactive Streams publisher. And then what we have is what do we have? We have a collection of tweets, but we don't want the tweets. We want the hashtags, don't we? So for each tweet, we want to get the hashtags, right? And we want to say Java converters dot as Scala set dot to set. Okay. And then we want to take the data that comes back, and we want to reduce it. So we want to create a collection of collections here, right? So we're going to say A, B, and we're just going to join them together, right? These are collections. We're going to add them to each other. Basically, that's what this is doing. Adding collections of things to each other, or appending them to each other. And then from there, we want to flatten everything. So we're going to take the collection of collections and flatten it into just a collection of whatever we've got inside the collections, right? So we're going to use the map concat callback here, and we're going to tell it to use this function called identity, which basically says, given A, return an iterable of A, right? So that's what we're doing there. And then, finally, we want to take the data that we've got coming in from that source, and we want to run it. We want to actually terminate the definition and do something with it. Well, here we have a number of different things that we could do, but what I want to do is I want to take the data and use a sync, right? So I'm going to say, first of all, try and get this to get imported. All right. As publisher, true. And in order for us to use this, we need to provide a materializer, an actor materializer. And well, the materializer mechanism in Akka Streams is it's what is used to deploy and then run the definition, the pipeline here. So it says source from publisher, then these processing operations happen, and so on. So we have to. This is just it's a graph, if you will. Up until here, you've got a graph definition, but there's no telling how and where the components in the graph will get executed. So it's up to you to provide a materializer. Well, one materializer that's very convenient is called an actor materializer. It's just a materializer that delegates to Akka, which is an actor system that runs. In this case, it's local actor. So we're going to say we're going to create some Akka bits. We're going to create the Akka actor system and the actor materializer based on that, right? So Akka configuration bean def actor system equals actor system dot create Bootiful Scala. Okay. Then we're going to create another bean here, def actor Materializer equals actor Materializer dot create this dot actor system. There we are. So we've got now these two different components, and we're going to take advantage of that Materializer here. We'll say am actor Materializer, very good, and we'll pass that in. So am. Now notice that I'm providing here an implicit parameter. I could define this as an implicit variable somewhere, or I can just explicitly pass it in here, which is what I'm doing. It's an optional parameter. If there's an implicit type somewhere, which is to say if there's an implicit variable defined in scope, then any place where that type is defined, or rather any place where that type is needed and it's marked as implicit, Scala will look in the enclosing scope or enclosing scopes and look for something that defines that type, and it'll provide it for us automatically. So if you've got parameters that are passed into method calls to a number of successive method calls, but you know you're going to define it once and you can define it before you call those different method calls, you can define it as an implicit scoped thing, and it'll just be automatically assumed to be the parameter. It's a little bit magic if you haven't seen it before, but it does make things a lot more concise, and it lends itself to building really nice DSLs. Okay, so in this case, though, we're just going to be very explicit. We're going to say use this actor Materializer. This is the one that Spring has provided for us. This, by the way, is the constructor syntax. If you've used Kotlin before, this will seem very familiar. This is a constructor. It's not the only one, of course, but we're creating a constructor. We're telling Scala that we want to create a bean, a JVM object that has a constructor with two properties. One is called tr and one is called am, and we can reference these constructor parameters within the body of method. So it's as though we got a constructor plus a field, right? A reference there. All right, so that gives us back a publisher. Let's just be very clear and explicit about it, but it does. It gives us a publisher that we can use. And here we have a publisher of tweet. And because Spring WebFlux natively knows what to do with publishers, this should just work, right? I'm not using Reactor or anything else. I'm just using the Reactive Streams initiative and the Spring WebFlux API, which is built around the Reactive Streams specification. All right, so let's see. Run this again, and we want to have a REST endpoint, don't we? So we'll say array of hashtags. We're going to call it the hashtags unique endpoint. Hashtags publisher of hashtag equals ts dot hashtags. Okay. Run that again. Hashtags unique. All right. So there's our new endpoint created using the Akka Streams project, and so we've just created a very simple example here, right? We've got a very simple example, but there are several things that should stand out. First of all, this isn't all that different from Kotlin or Groovy or any other sort of modern language, and in some respects, it's not all that different from Java 8, right? Keep in mind, Martin Odersky, the creator of Scala, was one of the people that worked on the on Java itself years ago. So he kept a lot of the good stuff from Java. A lot of the things that didn't need to change haven't, right? So you notice that we use the word extends to extend other types, for example, right? So a lot of things should feel very, very familiar, and there are concessions to the fact that you need to be able to interop with other JVM technologies, and that's why you have this ability to synthesize bean properties fairly readily. We looked at functional programming here. You can see it's very easy, even without any sort of reactive context, to process data, to split it up, to use pattern matching in this case, which is what we're doing here, using case to make short work of otherwise sort of tedious kind of processing. This kind of thing would have been an if statement, and that wouldn't have been an expression, and because everything in Scala is an expression, this becomes a very clean thing that I can compose. I can write as just a bunch of expressions, one after the other, as opposed to having intermediate variables, right? That's convenient. Also, we have these case classes, and these make short work of defining, very common things, GTOs or things that we use to just ferry data back and forth from one layer of the stack to another. This is natural to write in Scala, but it also it works just fine, just as we expect it to with Spring and so on, with everything else. You can see that the code that you write in Spring is, it still works, still valuable, still useful here, but you can also take advantage of some of the other projects out there, right? Some of the other projects that maybe you want to take advantage of, or maybe conversely, maybe you've already got them and you want to also take advantage of the Spring ecosystem. So this is all, so far we've looked at a sort of very traditional sort of Spring application, and I'm using a REST controller here. I'm using where's my REST controller? I'm using a REST controller here to define the REST endpoints. That said, it's worth keeping in mind that thanks to the functional reactive endpoints inside of a Spring 5, we can also build this a different way. We can say class tweet route configuration, right? So tweet route configuration, it's just a configuration object, and here we're going to define a route definition. Router functions dot route, and we'll say at mean, of course. And what we're going to do here instead is we're going to say that we want to inject the tweet service. So there's this, and we'll say that we want to make an HTTP GET call. So request predicates dot get, and we'll say tweets, and I have to provide a handler function. Again, this is a fairly easy thing to do because it's a functional interface, and I'm going to say request server response dot OK dot body equals tweet service dot tweets, specifying for the second parameter here that it's a class of tweet. Okay. All right, so there's that. Now, several things are happening here that it's kind of worth understanding. First of all, we have a lot of extra types here. We have predicated types or qualified type references. So we can use the equivalent of static imports here by saying import all members of that. That makes it a fair bit cleaner, right? Look at that. Also, we have a lambda here, but I don't really care about this parameter. I'm not using it at all. So really, it's just useless. I could just drop the name, and it's very common in Scala to see underscore. That just says give it any old name. We're acknowledging that it's there, but we don't care about it, so it's unimportant. Okay, so that's one route. Now I want to have the other route for the hashtag, so I'm going to create another route. Get tweets. I'm going to call this hashtags unique, and same as before. OK dot body tweet service dot hashtags class of hashtag. All right, there we are. So now if we run this configuration, this functional reactive style of building a REST API is, I think, very convenient. It's much more concise in this case, so let's go ahead and restart that now. Much more concise in this case, and ultimately you get the same result, right? It's just a matter of style, just a matter of what you prefer. All right, so we've looked at Scala. We looked at setting up a new project in Scala. We built a simple REST API, and then we turned it into a functional reactive REST API. If you saw any of my previous videos or talks on Spring 5 and Spring WebFlux, that shouldn't be all that unfamiliar to you. And if you've seen any of my previous talks on using Kotlin with Spring, then a lot of this shouldn't feel all that unfamiliar to you. And if you've seen any of my talks on using Spring Boot, then again, that shouldn't feel all that unfamiliar to you. So really, Scala is a nice language. It's it's a little different here and there for the common things that you're likely going to do, especially when interacting with the Spring ecosystem. If you've got the patience to set up what small things we had to set up here to get the build going, then you can be quite productive very quickly. And I know a lot of people that are using many languages besides Java, lots of different languages besides Java with the Spring ecosystem. So hopefully this gets you started and productive. So with that, thanks for watching, and we'll see you next time.